Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into what are dynamic clients to talk to the Kubernetes API server. So in all the videos that we have been looking into, we just used typed clients to communicate with Kubernetes API server. But in this particular video, we are going to look into the use cases where you would want to use dynamic clients, dynamic Kubernetes client, let's say. So before actually going there, let's quickly have a look into this particular very small project that we wrote in one of the previous videos, where we used a typed client to actually list all the pods from default namespace. This particular source code is already pushed into my GitHub repo with repo name lister. So if you want to find that out, I would link this down in the description. So I'm pretty sure that you would be familiar with this particular pattern here. So we try to figure out where exactly the kube config file is, and using that config file, we try to create the typed client here. So if you see from Kubernetes module, we are calling new for config, specifying the rest.config that we have. And this rest.config is actually your kube config file. Very naively, we can say that this is your kube config file. Or if you are in inside a pod, in that case, this is how it's formed. So it's basically it basically uses the service account that is mounted. So if we look into new for config here, you see it gets us client set. And if we look into this client set structs, if you see here, this is giving us all these typed clients. So if you see here, when I say typed, it simply means that we actually know if we want to interact with a particular resource, and if we know which particular group and version that resource is part of, we can use these typed clients to interact with that resource. So for example, let's say we called new for config. New for config gets us client set. And let's say if we have to interact with deployments, let's say, in that case, we know that deployments are part of apps group and v1 version. So if you see here, we have a typed client for apps group and v1 version. Similarly, we can see that we have a lot of other clients as well for that particular group and version. So in other words, we can say that in this particular scenario, we know that which particular group and version our resource is part of, and that is the reason we are going to get the typed client for that specific resource. Similarly, let's say if there is a resource that we want to interact with that belongs to networking v1, in that case we are going to call networking v1 on client set, because again, let's say ingresses are part of networking v1. So because we know that ingresses are part of networking v1, we can use this typed client to interact with ingress resources. When we say interact with, I mean, let's say doing something with ingress resources, for example, creating, deleting, updating, etc. So this is what a typed client is, that we have been using up until now. But let's say if we have a typed client, then what exactly is the need for the dynamic clients? So let's assume we have a Kubernetes cluster. So let's say this is our Kubernetes cluster, and in this particular Kubernetes cluster, we have n number of resources. Some of those resources are pod, and let's say the other resource is service, and there is this another resource that is introduced by another component. Let's say we don't know which particular component is that, we don't know who deployed that, but there is this another controller, let's say, or operator and this operator created another resource, and this resource is named, let's say cluster. So now we have these three resources in the cluster. Now, if we have to, let's say we are writing another application, and that application needs to, this application needs to interact with cluster resources. So if this application has to communicate with pod or service resources, in that case, we know that Kubernetes Client Go has typed clients that we just looked into. Using those typed clients, we can interact with Kubernetes native resources. But for a new custom resource that was introduced by another component, let's say, in that case, we don't actually have client set to interact with this particular custom resource, because there are chances that when developers of this operator developed this operator, they generated client set for cluster resource, but obviously we don't have access to those client set libraries. So this is one problem. Let's say we have to manage a particular custom resource, and we don't have client set to interact with that custom resource. So in that case, this is the first use case where you would want to use dynamic clients. And in case of dynamic clients, you don't actually have to have the client set code generated. You can use dynamic clients specifying the group version and resource of the resource that you want to interact with, and you would be able to do all those things. For example, getting, listing, deleting the resource, etc. That is the first use case where you would want to use dynamic clients. The other use case that I can think of is, let's say, even if in some of the cases, let's say you are interacting with Kubernetes native resources itself, but you don't actually know, you just have group version resource information with you. You don't actually have the information on which particular typed client should be used. So let's say you have a function, and the only responsibility of that function is to get resource with a particular name, and that resource can be anything. That resource can be pod, service, network policy, or anything else. And you just have group version resource and name of that resource. So in that case, you can very easily use dynamic clients to actually get that resource. So that is the second use case where we would want to use dynamic clients. Now, if we talk about the third use case, so let's say there is this resource in the cluster in your Kubernetes cluster, named cluster, or let's say it's named anything else. Let's say MongoDB. So in that case, if you want to get notified for the creation events on these resources, again, the operator that introduced these resources, there are chances that that operator has all that code generated. We have already looked into the code generation, etc., but we don't have access to that code. That is the reason, again, we would want to use dynamic clients, dynamic informers, to get notified about creation, deletion, or updation of these resources. So these are some of the use cases where we would want to use dynamic clients. Now that we know what exactly is the use case where you would want to use dynamic clients, let's just go ahead and try to write something that uses dynamic clients. So I'm going to create a new directory named dynamic client, and cd into that. So we already looked into this lister code that we have here. We have already talked about it. So I'm just going to copy this particular part from this code, and I'm just going to copy that here. if you do not understand this, I would link the video down in the description. You should watch that video. I'm trying to copy some of the code just to make sure, just to save some time. So now, if we talk about this particular code, if you see here, we have already said that we are trying to use typed client here, and that is the reason we are calling Kubernetes.new for config. But in the cases where we want to use dynamic client, in that case, what we can do is we can use this particular package from client go, and using this particular package, we can create dynamic client instead of typed client. So let's go ahead and try to do that. So we have to make sure that we have initialized the Go project successfully. So that's what we are going to do. So new for config, if you look at the definition, new for config creates a new dynamic client, and this is what we want to create, and we have to pass config, and we also have to import client cmd. So let's try to do that. And as we know, new for config from dynamic module, from dynamic package, gets us dynamic client. So let's name it dynamic client, colon, comma, error, colon, equals to this is not how you would handle the errors in actual code, but I'm just trying to show you the things. Now let's assume we want to get like we discussed in this particular diagram. Let's say there is this cluster crd that is available, and we want to get all the cluster resources. So what we can do is we can use dynamic client dot resource, and resource accepts group version resource struct here. If you see it accepts group version resource, and we can pass group version resource for that particular resource that we want to interact with. So let's initialize schema dot group version resource, and then dot, let's say, get, and get expects context, I think, and it expects name. So let's not run get, but let's do list, and let's expects context dot background options, list options. So list options is from meta v1 dot list options. So wait, something seems to be wrong. Just give me a second. we see list options here. Why are we not able to use that? Okay, we see that now. So yeah, and it gets us all the resources. Let's say resources colon error equals to this. If error is not equals to nil, in that case fmt dot printf error getting resource from dynamic client, and error is but if we were able to get the resources successfully, let's okay, so if you see here, it gets us unstructured list, and let's just go ahead and try to print the length of items. So length of items from dot list is, and now let me quickly try to explain this. So as I said, we don't actually want typed clients. That is typed client. That is the reason we are not using Kubernetes dot new for config. We want dynamic client, and we know why we want dynamic client. And we have already talked about that. That is the reason we are using new for config from dynamic package, and it gets us dynamic client, and from dynamic client we are specifying a particular resource that we want to list. We have made a problem here. We have not specified the resource yet that we are going to do in just a bit. So, and this is the syntax. This is the syntax using which we can interact with the resources using dynamic client. Now we can also specify the namespace here, but if we do not specify the namespace, by default it's going to consider all namespaces. So here we can also specify namespace. If you see, so we can specify obviously namespace, but we are not specifying any namespace. That simply means we are interested in listing the resources from all the namespaces. Now let's actually decide which particular resource we want to list, and we have to specify group. We also have to specify version, and we have to specify resource. And let's assume there is this crd in the cluster. So right now we don't have any crds. Let's go ahead and try to create one. So this creates a crd. If we get all the crds now, we can see one crd. Now let's go ahead and try to create some CRs for this TRD. So create -f one and two. So we basically have to cluster resources, and these are the resources that we are going to interact with, or we are going to get. Now how do we figure out group version resource for this particular crd? So if we look into any crd manifest, we will be able to figure out which particular group and version that resource is part of, because when we create a crd we specify all these things. So if you see here in the specification, we are specifying the group to be viveksingh.dev. So obviously this is the group that we are going to specify here. And you will also be able to see the versions. So for versions we have name, and for name we have specified v1 alpha 1. So this is the name that we are talking about, and resource obviously is clusters. So yeah, if we try to summarize this again, what we are trying to do is we are specifying which particular resource we want to interact with using schema.group version resource, and we are calling that in dynamic client. So let's go ahead and try to build this. So go build, And here we go. We are able to see the binary has been created. And if we execute, length of items from dot list is 2, and the reason is we have two cluster resources. So if you see, we have two cluster resources, and that is the reason we see two here. If we, for example, delete one, delete -f cluster one, in that case, we would just have one cluster resource, and in that case, this should return one. So if you see here, we are successfully able to interact with this particular CRD, even though we don't have client set generated for that particular CRD. So this is a very powerful feature of dynamic clients, I would say. And actual use case, if I try to share where this particular thing is used. So for example, let's say if you have a product that interacts with, let's say, VolumeSnapshot APIs, in that case, there are chances that you would use dynamic clients for VolumeSnapshot APIs. And the reason is, we know that volume snapshots are not actually shipped. They are by default shipped by default. They are actually installed on Kubernetes clusters using CRDs. So it simply means that if they are installed using CRDs, we don't have access to their client sets. So we will have to use dynamic clients to interact with volume snapshot APIs. For example, volume snapshots, volume snapshot classes, and volume snapshot contents. So I hope this makes sense. Now the other thing that I want to talk about is, for example, let's say I I don't want to actually list all the resources. I want to get one particular resource. So in that case, what we are going to do is we are going to use get, and get expects context. Context, it also expects name is a string, and then it expects, sorry about that, meta v1 dot get options. And if we try to if we try to look into the output of get here, it returns us unstructured dot unstructured. But if we look into any typed client, so let's say if we used, again, I opened the other project that we have been looking into. So we got the typed client, and if we, let's say, try to run get here, and the return type of get is pod. So if you see here, we are actually getting a type out of that get call, and that is the main reason between typed clients and dynamic client. So if you are using typed clients, it simply means that we are eventually going to get a type out of that call. But in case of dynamic clients, if you see here, if we call get, we are not actually getting a concrete type, I would say, but we are getting this structure named unstructured, and this is from package API machinery and unstructured. So let's go ahead and let's just call it unstructured object, and let's say we are trying to get the resource named cluster 0. And the other thing that I want to talk about is how, let's say, we got the unstructured object, and there are some utility methods that are already available in unstructured type that can be used to either get or set a particular field of the object. So let's go ahead and try to look into those. So we are going to look into two things: getting and setting fields of unstructured object. And we are also going to look into how do I convert unstructured object into a typed object. So if we, for example, say fmt.printf got the object %s and unstructured object dot get name. So like I said, there are already some utility methods available on this unstructured object. If you see here, these are all the methods, I would say, on unstructured that can be used to either get or set the fields. So let's go ahead and try to run this. So if I run, I'm building the project again, and if I try to run this, it says it says it basically broke because we have not handled the things correctly, and there is no resource with name cluster 0. So let's change it to cluster 1, and then we are going to build it again, and then okay, uh, just give me a second. Let's try to figure this out. So the problem is at main.go42. Okay, so it so is we are getting at this particular location. It says the server could not find the requested resource, and it simply means that I don't exactly know what the problem is. The server could not find the requested resource is the problem. This is pretty standard Kubernetes problem, I would say. So I don't understand how list is working in that case. I'm just trying to use the list again to check if it works, and it is failing just for get somehow. I'm just trying to cross check group and version. figure out what exactly the problem is. And it looks like, so we get this particular problem when when the client is not able to figure out if the resource is even being served by the API server or not. In other words, when the client doesn't know if the resource is available or not. So it looks like if we specify the namespace here, and for namespace, let's say if you specify empty string, it simply means that we are interested. We want to get the things from all the namespaces, or let's say we specify default. So we are trying to get the things from default namespace. Now, if we try to build the project and try to run the things again, if you see, we got the object. So we are able to get the name of the object using get name method on the unstructured type. So it looks like even in case of list, we used dot list without dot namespace, and that seemed to work. But it looks like we cannot use dot get without specifying norms, without specifying namespace. Maybe the reason is that the cluster resource is namespaced. That is the reason we cannot use dot get without namespace specifying it. But again, I'm not very sure about that. I have not encountered that before, but fortunately we were able to resolve that. So the other thing that I wanted to talk about is we know that there are a lot of utility methods, for example, to get and set the things, and you can look at all these methods by going to this package unstructured. So we have get name, we have other getters as well. So for example, dot, if you see here, get API version, get finalizers, kind, labels, etc. But let's say we know that we are trying to get the clusters resource. So what if our requirement is to now convert this unstructured object into a typed object, into a specific type that we are interacting with? And we know that we are interacting with a type cluster. So what we can do is we can also convert this unstructured type to a concrete type as well. So to do that, what we can do is first have a variable of type cluster, and we are going to convert unstructured object into that variable. So we have a project in our GitHub repo, that is cluster, where we wrote an operator, and that operator is what we are using here for a second, just to introduce the CRDs. So if we go to the types here, we can see the cluster type here, and this is the type that we are trying to get, that we are interacting with at this particular location. So let's import this. So we are going to create a variable of that type. So var k is of type v1 alpha 1 dot cluster. And let's say we have to convert this unstructured type into this cluster type. To do that, what we can do is we can use another package from upstream. So this is the package that we have to use, and this actually is from API machinery and runtime. And there is this utility that we can, I would say, a variable that gets us unstructured converter, and this is what we can use to actually convert an unstructured type to actually a concrete type. So let's go ahead and try to do that. So first of all, we'll have to get hold of this variable. So let's try to import this package first. So runtime dot, we are just trying to download all these new packages that we just imported just to make sure that. Okay, this is another problem that we will have to fix. Let's go ahead and try to fix that very quickly. So we are using this another library in cluster. That is the reason we are that is the reason this is breaking. So if we use this, now we should be able to. Okay, so and we know that we have to use runtime dot default unstructured converter, and then we know that default unstructured converter is a variable in this package that gets us unstructured converter, and this unstructured converter has a method from unstructured, and that can be used to convert an unstructured type to a concrete type. So let's go ahead and try to do that. So unstructured converter, and then from unstructured, and from unstructured, if you see here, it says from unstructured converts an object from this representation into a concrete type. So we have to specify unstructured object here, and we also have to specify a, and it gets us error. So let's make sure that we do not get into an error. So if error is not equals to nil, in that case we are just going to print it. So error percentage s converting unstructured to cluster type. And if everything works as expected, we should be able to convert that. So we are building the project. Project was built successfully. Okay, so the problem is, again, it says it should not be, it should be an instance basically. So we have to change that to this. Requires a non-null pointer to an object, got v1 alpha 1 dot cluster. And now it simply means that we have to specify reference of this variable here that we have, or an instance that we have initialized here. So now if you see here, what we have done is, using dot get here, we use dynamic client to get a cluster resource named cluster 0. When we got the unstructured, because again we are not using typed client, we are going to get unstructured resource, unstructured type, and once we got that, we are trying to convert that to concrete type using runtime's default unstructured converter, and then from unstructured from unstructured method, and it expects the unstructured object and then the variable where you want to convert that unstructured type to. And once we have converted that, let's go ahead and try to just print that. So the concrete type that we got is percentage plus v. Let's see if we get the expected thing. So go build, and we are going to run this again. So if you see here, this is the type that we got, and this is the type that we are going to get if we run kubectl get cluster and cluster 0. So hyphen o YAML. This is the exact same thing that we are getting in here as well. So if you see name dummy node pool count 3, and this is the same thing that we have specified here. So yeah, this is another thing that I wanted to talk about. So basically, how do we interact with resources using dynamic client? How do we convert an unstructured type to a concrete type? And the other thing that I wanted to talk about is how to use dynamic informers. So for example, let's say you are writing a controller that wants to know if when a particular custom resource was either created or deleted, and let's assume we don't have code generated for that client, because like if we look at this diagram again, this particular, if you see here, this operator was not actually developed. Let's assume this operator was not developed by us. This operator introduced this particular custom resource, and obviously when we don't have the code generated code with us, we are going to use dynamic clients or dynamic informers. So we looked into how we can use dynamic clients. Now let's go ahead and try to look into how do we use dynamic informers. So let's say we want to use very simple controller that is just going to print that a resource was created as soon as a cluster resource was created. So let's introduce another file named controller.go, and have uh, this is going to have a type called controller. Again, I'm not going to explain these things in very much detail, because this skeleton has already been talked about in a lot of my videos, where we wrote a controller from scratch and an operator from scratch. So type controller, it is going to have, let's say, a dynamic client. So we are going to say dynamic dot interface, and this is also going to have I would say informer, so that we can make sure that cache has been synced. But before that, let's write new controller, and in here we are actually going to return, it returns a controller, and client dynamic dot interface. What we can do is we will also have to if we try to go ahead and look into one of our examples, let's say expose, and in expose, if we look into controller.go, if you see here, we try to register these functions in the informer. So what we'll have to do is we have to get informer as well. So let's say we are calling it dynamic informer, and this is going to be from package dynamic informer. And let's go ahead and try to build this. So if you see here again, when we use dynamic informer, we can if you see here we can again specify which particular resource we want to get. We want to get the informer for. So if you see here dynamic informer dot for resource, and again we can specify group version resource here as well. So we can specify schema dot group version resource, and again we can specify group and version and resource as well. And when we call informer here, I think we would get the actual informer instance for that resource. And informer returns shared informer. So we are going to initialize, let's say, informer. And now what we can do is we can actually register events on that informer. So if you see here, this is how we can register the events. So let's go ahead and try to do that. So informer dot add event handler, and again if we try to compare it with this particular code here, we can use the exact same thing. So cache dot resource event handlers, and we can specify add func. And now we are basically have set up a very basic skeleton that is going to respond to creation of cluster resources. Again we have to specify. And from main.go, we are actually going to call that new controller. So new controller, and we are going to pass client, and it expects, if you see here, dynamic shared informer factory, and we can create that from, just give me a second. So if you see here from dynamic informer, we can call new dynamic shared informer factory, and it expects dynamic client, and it also expects default resync time. Again, I'm not going to talk about default resync time in this video because I have already talked about in other videos. So let's say that we are going to make that 10 minutes, and this gets us informer factory. And I think it also returns error. No, just informer factory. And we are going to pass that to new controller. And once we have the controller, what we can do is we can actually run the controller. So we are going to have another method here. Let's say func run, and that is actually going to do the things. So yeah, I think I am going to complete this code offline. There are just going to be one or two more lines here, but this video has already been too lengthy. So I think this is again, if I try to summarize this very quickly, we already talked about in which cases we would want to use dynamic clients and dynamic informers. Let's say there was some CRs introduced by another product, another operator. We don't have access to client sets. In that case, we will have to use dynamic clients to interact with that resource. Uh, once we have got the once we have gotten the unstructured object by get call, we can actually convert that into typed client using runtime.default unstructured converter. And the other thing that we should also make note of is there are already some methods, utility methods exposed on unstructured object that can be used to get and set the things. So I highly recommend going to this particular source file and looking into what are all the things that are available. So, and lastly, we also looked into how we can use dynamic informers to actually create controllers for the CRs that we don't have generated code for. So yeah, I hope I'm going to push this to a GitHub repo named dyn-client so that you can check that out. If you have, the only thing that is left here is we are going to just start the informer, and that's pretty much it. And we are going to push that. I'm going to push that code in my GitHub repo. If you liked this video, click the like button, subscribe to the channel, share it with your friends, colleagues, and classmates, and I'll see you in the next one. Thank you so much.